Right. Good. So, hi everybody. This is the Holiday Tech Talk. My name is Kostya, and with me today I have Ed Klotz, our senior mathematical specialist, and Richard Oberdiek from the technical account management team, and both worked with I think the whole Gurobi tech team to put together what we have today. It's a special edition. It's tips and tricks to prevent the Grinch from stealing your optimization projects. And people are probably already wondering what that could be. So this issue is quite special in the sense that we probably wouldn't get, marketing approval for the concept, but we do it anyway. Instead of talking about, shiny features of the product, we talk about strange or unexpected or inexplicable behavior. And why do we do it? Because there's a lot that can be learned from it. And it's not everything that is strange or unexpected is bad. It's a learning opportunity. So we try to put together quite a bit of material to help our users to better understand what's going on behind the scenes. Sometimes it's also a bit embarrassing, but in most cases, I think there's something to be learned. In order to submit questions, there is the Q&A panel. Please use that. Don't use the chat. And we will get to questions, during the tech talk. And most of the time we spend, a few more minutes after the full hour to answer all the questions. Good. All right. Richard, do you want to kick it off?
Yes. Hello, everybody. And it's good to be back. And some of you may be aware that the Tech Talks are a recurring theme here at Gurobi, but it's been a while since we had one of those. In fact, it's been almost 6 months at this point. And really, you may ask what's going on, and it's really been a really long time, but for a very good reason. Because what happened is that after our last Tech Talk, we went into our cave, Ed and I, respectively, and we put together the material from the last two Tech Talks, which was about converting weak to strong MIP formulations, and put all of that into a book chapter. So this book chapter is really putting into written form what we talked about in the last two Tech Talks, and this is currently under review and will be available in 2023. But in the meantime, this was a lot of work, and therefore we didn't have the ability to host another Tech Talk. There was also releases and other things going on. But now finally we are back in action and ready to go. And as Kostya said, today we're going to be talking about the Grinch. And the Grinch is somebody who always throws a rod in your cogs of optimization. And so my first question for you today is, how often do you run into inexplicable Gurobi behavior? Is that every day? Is it every once in a while? Never? Or what's Gurobi? Just to see where everybody is on the scale, the Grinch scale, so to speak, if we want to put it that way. Okay.
And by now it's a tradition that we guess a little. I'm out of the game because I can see the results live. So I think, Richard, do you want to start?
Oh, no. Ed has a very good track record here, so I have to think. So I think the majority will be every once in a while at 60%, followed by every day at 20%. This is just going to be our frustrated users who just want to vent. And then there's going to be never at 10%, and there's going to be some people saying, what's Gurobi, just for the fun of it, also at 10%. Ed, what do you think?
Yeah, I'm going to say 70% every once in a while, 10% every day, and let's see, what else? Whatever, 5%, 5% what's Gurobi, and whatever's left, never. I guess 15%.
Ed, how do you do this? I mean, if this was a regression model, yeah, the error would be tiny. Yeah, really good, really good. But so conclusion, 2/3 of people on the Tech Talk in the audience say that, they run every once in a while. There's something that they can't explain. So it's the right place to be here today. And those saying that it's every day, come on. And what's
Throwing
Gurobi
Gurobi in
is
place.
simply a fun question, because what's Gurobi is, you wouldn't be here if you hadn't subscribed to the newsletter, so you get the announcements. All right, let's move on.
So this is exactly what today is about, right? Today we talk about the optimization Grinch. And really, what's the Grinch? I mean, optimization as it is hard enough. I mean, there's university courses and lectures and all of those things, textbooks written about it. But sometimes, despite all of the already hard machinery around it, there is some inexplicable behavior that just quite frankly makes it scary to work with, and you don't really know what's going on. And there's can be a ton of reasons. Can be numerics, can be bug in your code, can be bug in Gurobi, can be, a lot of things. And today what we're going to do is we're going to open up the war chest of Gurobi stories, because in a way we're uniquely qualified, because when something weird happens, people call Gurobi, because when they're using Gurobi, because they're like, oh, this is strange, what's happening? And so we have collected over the years quite a wide range of stories where things just didn't work out, quite frankly. And so here we're gonna do a few juicy selections for you and show you what can happen. So how does that typically come about? Who is this Grinch, and how does he raise his head? So typically one common scenario is you sit there in front of your computer and I'm really late on my deliverable. I really need to get this going. Okay, Gurobi tells you, don't worry, here in an example library, here's a script, whatever. You can get started. It's like, hey, yeah, awesome. I write this down, I put this in. All I need to do now is to get this to run. When I press the button, just has to give the right output, and I'm done. But then the Grinch appears and says, nah, not so fast. We're going to have a word, you and I. And so this Grinch is somebody who throws, just at the last turn of the circuit, throws you an obstacle in your way. But this Grinch, as we'll see, is not really an evil person. And so this is the quote from the book. And the quote really shows also what the optimization Grinch is all about. It could be that his head wasn't screwed on just right. It could be perhaps his shoes were too tight. But I think that the most likely reason of all may have been that his heart was 2 sizes too small. So it's not like the Grinch is deliberately being evil. It's just that he's trying to get attention and trying to make sure that you fully appreciate what you're trying to do. And we'll see as we go through this presentation that this heart is gradually growing until we hopefully can make the heart of the Grinch whole again. So let's dive right in, and let's start with the first Grinch of the day. Where can we find this one? So this is the maths Grinch. And this is the maths Grinch. That's one where when it doesn't quite check out the maths, then he's all raising his head and being very, very, very peculiar. So what we're going to do here, I'm going to this quote that you see up here. This was an almost verbatim quote, support request that we got a few months ago, where a desperate customer, emails us and says, or writes to us and says, I'm having issues where as I increase the value of capacity, so this is some sort of production problem where you have a capacity, this is the right-hand side value of the constraint, so less or equal than a number, right? And that number is increased. The model is reported as non-convex. I will attach 2 MPS files, one where Gurobi reports the problem as non-convex, and the other one where it resolves as convex. So this MPS files are just file versions of this problem, and then the Gurobi detective, in this case it was Malihe, our colleague in Canada, she took this took the support request and looked at it, and she started being the detective here, and she started looking and she saw, wait a minute, okay, so first of all, this is an MIQP, so this is interesting. So it's a mixed integer quadratic programming problem. It has continuous elements, it has discrete elements, and it has a quadratic objective function. Then she looked and saw that in the objective function, some of the coefficients went from 25 to 75. That's interesting. Between these 2 MPS files, so one from the convex, it wasn't 25, non-convex, it went to 75. Then she compared the convex and non-convex and saw that the right-hand side coefficients, this capacity value that this person was reporting, went from 50 to 150. And then finally she saw that there were some indicator constraints. So this is if then. So if this happens then, for those, the coefficients also change from 50 to 150. And then the big question mark appeared, which I'm going to relay to you. What's going on here? Which one of these is the culprit? Which one of these changes suddenly makes your problem or this problem non-convex? Let's have a look at what you guys think. Kostya, I can't see the question, by the way.
Wait a second. This is, oh yeah, my bad. Wait a second. So pause this. Now it should
There
be
we
there.
go.
Yes,
Okay,
now it's there.
we're
Thank
now.
you. Okay, so is it the MIQP? Is it the objective function? Is it the constraints? It's a combination of the right-hand side and indicators, or is it a combination? Ed, I think you have bragging rights at this point. What's the split gonna be?
I'm gonna say 40%, no, 50% a combination, 35% constraints, right-hand side and indicators, 10% objective function, 5% MIQP.
Okay. I actually think that we're gonna have 2% objective function and we're gonna have 60% combination. Go with it.
Okay, no comment. I'll just share the results.
Ed, don't be right again. Ed, come on.
I mean, the error is slightly larger, but yeah, Ed has a run.
You know, I will comment about the objective function. You know, very few people said it's possible, but if you change an off diagonal of a quadratic matrix in a way that increases it, that does have the potential to turn a matrix from positive semi-definite to indefinite.
Yes.
So, you know, I would just say, don't be so quick to rule that one out.
No, that's true. That's true. I wouldn't have ruled it out if I was. So there's all legitimate reasons. Don't get me wrong.
Yeah.
But because the question talks about the right-hand side,
yeah,
I was thinking that people would focus more on that rather than the objective function. But of course, you're right. I mean, you can make your objective function very, very quickly non-convex just by changing the objective function values. So what happened here? Let's look under the hood. And what happened here is that our detective here did the exact thing that we just looked at. She looked at each individual option. What can be the culprit here? And she did some analysis, and this was her answer to the client in an abridged form. The problem is that the objective function in and of itself was non-convex. And the reason we got an error message for one of the models and not both is because of pre-solve. So because some of the constraints have different right-hand side values, it's possible that some of the reductions we do in pre-solve work differently, and therefore we cannot reduce the problem to a convex model. So, but basically that means is when we have pre-solve, when we apply pre-solve, we take the original model and make it smaller and make it massage it into place such that it is more suitable to be solved. And there's a ton of magic going on under the scenes to make this happen. And one of the things is doing reductions, which may impact the convexity of the model, if it's nonlinear. And to illustrate this a little bit, if you look at this very, very crude depiction down here, you have a function here that if you go to 50, it is still convex, right? But the moment you extend here further and you go to this barrier which is called 150, suddenly it's non-convex. right? So even though the function itself, the function itself in its entire domain is non-convex, in the subset of the feasible space, it is in fact convex when it's only restricted to 50, but becomes non-convex when you go to 150. And that really means that convexity, if that wasn't already obvious, depends on the data, right? And on top of this, always be aware that pre-solve changes the model drastically to make it easier to be solved. And that means whenever you have inexplicable behavior, pre-solve is always one of the possible reasons, because it can lead to confusing results. Ed.
So keep going, Richard. I'll weigh in after you're done with the moral of the story part.
No, it's pretty done. I mean, at the end of the day, data matters, and convexity is impacted by data. And pre-solve has a huge hand in massaging and modifying problems. So you need to be acutely aware of what it can do to your problem. That's all I wanted to say. Ed?
Okay, so all I want to add on the data matters side is to elaborate a little bit about one specific way where that's in play, which is problem modifications that tighten the model are fundamentally different from problem modifications that loosen the model. And that applies here in particular with the impact on pre-solve. But as we'll see later, it applies in other situations as well, beyond pre-solve and what pre-solve can do. But you tighten the model, pre-solve is probably going to make more reductions. You loosen a model, some of the reductions it made will go away. It may be able to now throw away some constraints, but overall, tightening the model is really different. And the second thing is this detective work that Malahay did of sort of filtering out, where you say, okay, is it the objective? Well, I'm going to get rid of the objective change. And if the issue persists, I know that the change in the objective doesn't matter. That notion of filtering things out to make it simpler is also very important beyond this particular example. And in all sorts of situations where you're trying to troubleshoot. So with that, I lower my hand.
Yeah, not too much to add here. I think one of the things that you can discuss in this context is the question, should a solver be nice and, try to essentially transform the model into something that can be solved with a different set of algorithms for whatever reason, usually because they are faster. If we don't, right, then we would error out right in the beginning and say, sorry, non-convex model, that doesn't work, or you set a parameter to make it work, but that will trigger more expensive algorithms. Or do we say, well, we'll try, right? That's what pre-solve does. We'll try and go round and round, and at some point, maybe we're lucky, and a tiny change in the data or in some model components can make a big difference of what we are able to achieve. And I tend to be on the try hard to make it easier side, even if that gives you sometimes this. I would call this behavior unstable, right? It really depends on your input, whether or not the solver throws an error and says, sorry, no, or just moves on. So it can happen. The usual rule of thumb is disable pre-solve. See if it makes a difference. See if that, if that gives you a different answer. And of course, look at your model without the solver. Yeah, if it says, hey, it could be solved, even though it was non-convex, but I don't care. If the solver is able to do it, take a closer look. If that might be a feature, not a bug, right? So that can happen, and it can also happen in other cases that we are able to transform something into something simpler, by detecting that a certain structure is not really needed when looking for an optimal solution, which is exactly what happens here, right? We essentially rule out a certain domain in the objective function.
One follow-up question to this though. What's the general, where does because that's your opinion about like erring on the side of making it work. what's the general mood, quote unquote, in the Groovy development team? Is the general mood more to say like be textbook consistent or make it work? Like where on that spectrum does the dev team as a whole fall?
And that one goes to you.
I think
That's
also to you, Kostya. Both of you.
Well, I'll try to answer it. That's an interesting question, and I'm not sure if there's a really specific trend, but I think the approach is more what we saw here. Try to solve it when possible. The one thing we don't want people doing is quietly solving an unintended problem. So this actually shows up with the non-convex solver in the sense that the one thing we don't want people doing is sort of solving an unintended model for some reason. So that's the one thing I think that we try to avoid. But I think this illustrates the sort of example of difficult choices when implementing the optimizer, in the sense that, you know, there's a reasonable argument for what we did, but there's also a reasonable argument for saying you should do the convexity check before doing pre-solve rather than after. And basically, you make your choice and you live with it, and you try to carefully weigh the pros and cons of each one. But then once you've made it, you pretty much need to stick with it, because changing it the other way is going to lead to conversion issues for people who were used to the current way, and then a new version comes out and changes it and potentially breaks their applications.
That would be another interesting ticket here. I upgraded from version 10 to version 11 Gurobi, and my model suddenly became non-convex. What's going on? That would also make it into this Grinch slide if it was to happen. Yes. But Kostya, has the behavior always been the same, or has that changed over the years?
So it's a dilemma, right? So you cannot have both. You cannot essentially work on performance all the time. So do everything you can to solve a set of models faster, at least on average. And on the same side, stay in it's really predictable. We will not, try to do certain things. Everything should be intended by the user. Reality is some of our users really know their intentions and really know that something is supposed or not supposed to happen. Others don't. Others rely more on what the solver is able to do. I don't think that if you ask for a trend, I would say in doubt, we would probably try hard to make it easier. And then sometimes these things happen. Fortunately, they are really rare. If you would ask our experts team how often they get something that, that suddenly a tiny change in the model created a change of the algorithms. That's not impossible, but it's rare. So we probably go for the rare exception, but for the greater benefit of increased performance when we do things like this.
Yes, indeed. Okay, moving on.
Sorry, one last thing.
Go for it.
This example could just as well have been phrased as, even though I don't know if we've had this ticket, I initially solved my model, and it was solved as an LP. And then I changed the right-hand side, and now it's solved as a MIP. And the reason is that pre-solve was able, on the tighter version, to remove all the integer variables in the problem.
Yes, that would be nice. I'm sure we've had this. I mean, we've had this at this point. We're at ticket number, I think 42,000 something. So in that sea of tickets, I'm pretty sure. There would be found somewhere. But yeah, that's also interesting.
It happened. I definitely remember cases with especially piecewise linear objective functions.
Yeah, exactly.
Right, just 1 point change.
Yeah, exactly.
Okay, I think we need to move on. We have so much more.
Yeah, but this is,
Grinchy
you see already,
material.
this is getting really nice. And piecewise linear approximations, and then reducing this is kind of one of my favorite topics personally, because I think it's magic at the end of the day. But anywho, let's go on. The next Grinch, which is slightly related. And by the way, before we move on, we can already see the heart ever so slightly grew with realizing the math Grinch. So we're getting ever so slightly closer to happiness here. So next Grinch on the list is the finite precision Grinch, and I'm pretty sure many of you have probably seen this one, but maybe not this particular version of it. So this Grinch is a stickler for exactness. So when you have anything that messes with the precision, then this guy is up and about. And the question I have for you here today is, if solving model A yields a feasible solution, then solving model B will also yield a feasible solution. Yes, no, or maybe.
Yeah. So anybody who is not too, people who don't use matrix notation every day.
Ah, yes. Oops.
Yeah,
Excuse
maybe
me.
we should just.
I should explain. So this is on the left hand side. My apologies. On the left hand side, we have a linear objective function and linear set of constraints. So this is just your average LP or MIP. And then on the right hand side, you have the exact same objective function in the linear part and the exact same linear constraints. The only thing added is a quadratic term. And the question now is, does that adding quadratic term to the objective function, does that make a difference for feasibility? So this XTQX is the only difference.
No, we didn't have a chance to guess.
Oh no, I would have said exactly this.
No.
Prove me
I'm
wrong.
looking at the time. We can't do 2-minute guessing. Yeah.
Sorry. You're right, Costa. Sometimes we enjoy ourselves a little bit too much on these talks.
I would have been wrong anyway. So.
No, Ed, don't say that. So interesting here. So we have I would say this result is best summarized at meh. Exactly. So we have half the people say maybe, but the rest splits between yes and no. So what can happen here? And so we're not going to spend too much time on this, but this is an interesting version, because what happens, one of the things that can happen when you have this model and you're solving it, is that we apply so-called a dual reduction. So what that means is that we'll take the quadratic term in the objective function, and that will make its way into the constraints like this. So you have t and then xtq to x less or equal than t. And then suddenly this can be very, very tricky. I'll let Ed explain the details, because I know you've struggled with this one quite a few times.
Yes. So once you do this transformation, and this transformation is specific to the barrier algorithm for quadratic constraints, you've now put this Q matrix into the linear system that Gurobi ultimately is going to solve during the barrier iterations. Similarly, if you chose to use one of Gurobi's simplex algorithms, well, we would not do this particular dual reduction. The Q matrix would work its way into the optimality conditions from which a basis is extracted that then defines the linear system. So if Q introduces some tolerance issues or creates some ill conditioning, you can get different results. So the takeaway is that the choice of algorithm matters. If you had an algorithm that did not allow Q to creep into the linear systems, solve to maintain feasible solutions, then this wouldn't be an issue. But such algorithms tend to be slower than the ones we've implemented. So you'd give something pretty serious up. So I think that's it. And also, we're assuming finite precision here, but if you had some exact solver environment, or are doing this in the context of textbook where there's no finite precision, then you wouldn't have to worry about that in that scenario either.
And that's really the main issue here at the end of the day, because if you see this question in a textbook, then the answer is obviously, of course, if A is feasible, B is also feasible. But then you have finite precision, and finite precision is a real thing that we see. 1/3 is not 0.33333, almost, but it's not quite, right? So be careful out there. But the other thing is, when you run into these things, I always say it's a bit counterintuitive, but it's a blessing in disguise. Because the moment you run into these, something's up, and you actually have a motivation to go back into your data pre-processing and look, what's going on? Why do I have precision problems? And then you can look into, can I round something? Am I getting something from my database which is not correct? Am I serializing something? Is there some truncation, et cetera, et cetera? And that's really ultimately will make your code and your application more robust. But it is a painful process, and it's a Grinchy process. And we've now approached it, and now the heart grew again a little bit more. But it is a real thing. So whenever something weird like this happens, then do think about your finite precision and look at your data coming in. So the next Grinch in line is one that I think many came here to see for. It's the Gurobi Grinch. So it's the one where that takes Gurobi run and throws it back into your face and says, no, there you go. I'm not going to have this. And I'm going to explain one to you right now that this was one I was personally involved in. So this little question right here cost me 2 days of my life to solve this one. So the model was a little bit more complex than this. This was from a customer, but this is the essence. So we have a model here that says, well, we have two binary variables, x and y. We say minimizing 5x plus 3y, and your subject equals to y equals to 1. Okay? And then, as I said, two binary variables. And then what we do is we write this model, we write it in Python, for example, and we write it to an MPS file. Right? An MPS file is a complete serialization of the model. So ordering is the same, floating point arithmetic is the same, so no precision issues here whatsoever. Right? You write it to a file, or you keep it in Python. And then you solve those two models. You read in the model from the MPS file back in. And my question is, when you read the model from a file or through Python, are the models exactly the same? Yes or no? So, Ed, now we're going to take a couple of seconds for you to work your magic. What do you think is going to be the answer here?
Well, I'm going to say people are going to meta think and say we wouldn't ask this if the answer is yes, because there's nothing to explain. So it's going to be 78% no, 22% yes.
No, I think people will. I think 77% no, 23% yes. Let's see. Come on, people.
I see a trend here. I see a trend here. People waiting until the guessing and then pick their favorite guesser and hitting that choice. No,
this is also
close.
Oh, so we're now in sort of the quantum, the Heisenberg uncertainty principle about
exactly.
Taking the measurement, doing the observation changes the result of the measurement.
Yeah, 2/3 say no, and it's probably fair to say this is meta thinking, right? I mean, look at this. You define a model, you write it to a file, you read it back in. It's supposed to be the same, right? No question. I mean, what the heck? But
that's
maybe it's not. Why, Richard? Why?
That's what I thought. So when we to pull back a little bit the curtains. So Gurobi has something. When you look at the log file, when you run Gurobi run. We can look at one a little bit later when we actually look at Gurobi. There is a section called model fingerprint. And that's basically a hash of the model characteristics of the model itself, and it supposedly uniquely defines a model. And that's really what we use in our support tickets every day. So when somebody sends us their MPS files for example, tuning, and they send us a log file with it, the first thing we do is we run those and we compare whether the fingerprint is the same on their machine or on their log file versus what we get. Because if the fingerprints match, the chances are incredibly high that it's actually the same model. But if the fingerprint is different, then they might not have sent us the same model. And then you might be doing a lot of work, days of tuning, and then only send it back to say, oh, wait, I made a mistake exporting the problem. And so that's the first thing we do, just to sanity check everything. And this is exactly what happened here. So this customer sent me the model, and I got the log file. I looked at the model. I was like, wait a minute, this doesn't match. Come on, man. And then not only did the fingerprint not match, actually a number of binary variables also didn't match. And I was like, okay, what did you do here? Because some of our customers are not, they make a mistake, they overwrite a file, whatever. And so he was very adamant though. He was like, no, this is correct. And after a few, hours back and forth on email, I told him, okay, send me a Python code. I believe you, but I can't, how am I supposed to check? So he did. So he sent me his Python code, and I was able to reproduce it. So in this particular case, you had these two different fingerprints, same exact model, or so I thought. What the hell was going on here? What was going on here was this particular line, y equals 1. So what Gurobi decided to do was, wait a minute, you're setting this variable to a fixed value. Then you don't need this information that it's a binary variable. You can forget about this. So when it was serializing to MPS, it would just ignore that it's a binary variable. It would just say it's continuous. And then the whole statistics changed. And of course, the computation of the fingerprint also changed. Because Gurobi decided, nah, screw it, we're just going to have fewer binary variables because who cares? Well, I cared. And then after 2 days of back and forth, and talking to the developers and, having GitHub issues and all these things, this was figured out and was fixed in the next technical release. But yeah, this Grinch, this thing cost me 2 days of going back and forth. And I had I've been working for Gurobi, and I had no clue. I did not know what was going on. It was completely inexplicable to me until Misha from our development team told me. By the way, I was like, oh, thanks. Ed.
So you might think upon hearing this that, well, you might ask the question, well, why would anybody in their right mind fix a binary to 1? But actually, it's a pretty common and reasonable practice. You have a model and you want to try a related model where instead of deleting something completely from your model, you just say, well, let's fix the activities associated with what we want to delete to something. So for example, you might have a facility location model and you want to solve a smaller version where you have decided on one facility and you just want to look at, well, what's the rest of the model? So you're not going to delete that facility and adjust all the constraints to reflect that deletion. You're just going to say, well, we'll fix that binary to 1 and see what the rest of the model looks like. So it's a common practice and it's a legitimate one.
Yes. And
so that's all I had on that regard.
Kostya, any comments?
Yeah. So this was a bug. So we've applied some magic too early. That we shouldn't have. That was the learning. And honestly, for the audience, if that happens to you, if you create a model and you call optimize, and the fingerprint you see there is different from then writing it out and reading it back in as an MPS file, we should talk. We'll send you a pen or something. But that is most likely unexpected behavior. Yeah, so the model fingerprint is supposed to be exactly the same because the MPS file format is supposed to be a bit by bit serialization of the in-memory representation of the original model.
Yeah, and this goes actually even further than this. If you see anything inexplicable, especially with Gurobi, if you see something, say something, right? Gurobi is not without mistakes. We try very, very hard, but unfortunately, there are bugs, and as with every software out there, and this is really just a reminder. Always, when you see something that doesn't quite add up, rather send it to us, and we might tell you, well, it's numerics. It's not, not nothing we can do. But every once in a while, it might actually be something that is a genuine bug on our side, and then it's very, very helpful because it's a combined effort to make Gurobi as robust as possible. The other thing is really take away the fingerprint is really a great way of checking the two models are the same. In this case, it was really this canary in the coal mine saying, oh wait, this is not working, because otherwise we would not have found this specific bug of changing the variable type when we serialize for a fixed variable, right? So it really helps, and it's a great tool for this kind of thing. So you can definitely use it as a sanity check when you go.
And maybe one additional remark, so people don't all start to ask for pens. So it's called model fingerprint, but essentially the information used to generate that fingerprint is not just the model. It's also attributes. It's also additional information like start values. So that is in there. So it's definitely more than just what's in the MPS file. So
Yes.
that's something to keep in mind.
Yes. So now, final Grinch from my side before I hand it over to Ed. And by the way, sorry, we see the head is the heart is ever so slightly growing. The standard Grinch, and this is the one that I really hate this guy. Oh my God, I hate this guy. So this is a standard Grinch. It's a Grinch that says everything should be precisely according to the standards. Otherwise, this is out. So to show you how this looks like, I'm gonna switch I'm gonna switch pages right here, and I'm gonna show you a very, very simple installment of the standard Grinch. And this is something that we saw in a ticket not too long ago with my colleague Allison. So what we have here is a very, very innocent model. And just before we get started, the .mps file stores the MIP start. So it's the start values when you're solving the MIP.
MST, you said MPS, MST.
Oops, MST, excuse me. So here what we do is very, very simple. We import GurobiPy, we create an empty model, we add 10 binary variables, and we give them the name X. And then we add one constraint that says X greater or equal than 5. And we sum the variables up as the objective function, minimize that, and we write the thing to the MPS file. Then we solve it, and we write the solution to an MST file. Nice and easy. And by the way, here we can see the model fingerprint showing up that we just discussed, right? Nice and easy, solution is 5, all good. And now we read this back in, all good, and we check whether everything is okay. The MIP start looks perfectly fine. But then let's go back up here, and add one little thing. So now we didn't change anything in the mathematics, nothing in the structure. All we did is change the name from X to #X. Run the same thing again. And now, what? Your MIP start is basically infinity. And what the hell is going on here? What? Just by the name doesn't have any bearing on the mathematics. Nothing. It doesn't appear in any of the matrix, in none of the transformations. We throw it out for the actual algorithms. But here you can see when you look at the MST file, what's the actual problem? Well, when you write the file, you actually write the name. And in the MST file format, the hash is a comment. So here it actually looks at it as a comment. So when you take this out again, and we run this, we see now it looks correct. And this is with version 10, and this is with the current build of Gurobi. This is the standard Grinch, and there's not much we can or want to do about it, quite frankly, because you are free to name your variables what you want. So to just put this back into, let's go back into the slideshow. Please, and for those of you who are listening, please, please, please stick to the Roman alphabet when you name stuff. No hyphens, no exclamation marks, no hashes, no question marks, no spaces, just Roman alphabet, A to Z. Also no numbers. Like you don't need to name your variable 1x. Like just don't. Okay? Let's just agree on this. Thank you very much. Appreciate it. The other thing is, and this is a general statement, IO is, in my experience as a developer, one of the most common failure modes. Whenever you have a service that writes something to somewhere or reads something from somewhere that is listening to, this is where really stuff happens, because the one moment it's in memory and you have it inside your system, it's much harder to have an issue there. But whenever you have data pass between services, this is when stuff really goes haywire. So be careful and test your interfaces thoroughly. So this is really the main takeaway from my side. And the heart has grown again. Quick comments from your side, Ed or Kostya, before we move on in the interview.
Yeah, I would probably soften your statement just a little.
Yeah,
so there's
okay.
But it's a good point. So the naming model components, so adding text information on them, is totally irrelevant for what a solver does. So it's purely for what the user wants to do with it, or to have ways of debugging it, getting some semantic information on the model components, for example, when looking at it later and not in the code. But people have started to use interesting characters everywhere. I'm speaking Unicode in general, emojis. Yeah, it's really nice to have a crying face emoji in a file name. But that has implications, and we are building a software library that is supposed to be compatible cross-platform. So sometimes we need to think of trade-offs between platforms that support and don't support certain things. And so far, we're trying to do it in a way that works well. But it might mean that some specialties are not supported, especially the full Unicode portfolio. And the point here is, there's something we could do, right? We could escape certain characters, but where do you start, right? I think this is an old problem in computer science, that you try to come up with code that, hey, prefix free, these types of things that you need to essentially develop something that is that works with every input. You can find something that it can be, that is what is it? It is essentially unique. Right, and you can go back and forth every time. With the comments, well, that's something that I don't know. Maybe we could fix it at some point, but maybe we could also do something like error, or send a warning and say, hey, by the way, there is stuff in your text information that may cause trouble. So maybe we can do a little bit on the user experience side, but in general, don't use text information within the solver. You are perfectly free to do that in your code, right? You create a model component and you have your own dictionary. Yeah, you say, okay, so this model component has, this emoji attached to it, no problem. But you don't necessarily use the solver to do this and use attributes or whatever for that. I think that would be my take on that Grinch, the standard Grinch. Ed, you unmuted yourself?
Yes, but I have nothing to add.
Okay. But then, Ed, I'm going to hand it over to you for your what do you call it? Your specific Grinches that you're going to show to us.
Right, but I think I need you to run.
No, you manage.
Oh, I have the pointer. Okay. So, let's look at a simple little example where we've got one constraint and two variables, and ask ourselves and take a look at a couple of different bases. And the slide, Richard, is not advancing.
Oops.
Oh, wait, was that you or me?
That was me. Try again.
No, I'm getting nothing. So I need you
Okay.
to advance. Okay. So let's look at this, and let's start with the situation where Y is basic and the pointer is not moving either.
Oops. Okay, then I'll take it from here.
Yeah. Why don't you move the pointer? All right. So suppose y is basic. All right. We got to set x to be non-basic, which means put it at a bound. We've only got one finite bound. We set x equals to 3. We plug it into the lone constraint. And what that implies is y is less than or equal to 1. However, we have this lower bound of y from the original problem of 1 plus 8 times 10 to the minus 8th. However, that is a violation, but a violation within Gurobi's default feasibility tolerance of 10 to the minus 6th. So this basis indicates the model has a feasible solution. Let's now think about the other branch where we say we're going to make x basic. We now make y non-basic by setting it to its only finite bound. And again, we do like we did before. We substitute this bound value of y into the constraint. Excuse me. And this yields a lower bound of 8 plus 24 times 8 times 10 to the minus 8th for x. And this 24 basically takes this value that was below our default feasibility tolerance with the other basis and makes it above the feasibility tolerance here. So we end up with a violation, and even worse, if we use this basis for phase 1 in the simplex method, we would find that moving either y or the slack variable on the constraint off their bounds does not resolve this violation. Therefore, phase 1 of the primal simplex method declares this model infeasible. Both of these are correct, okay? There's no ill conditioning here. So when a model is right on the boundary of feasibility and infeasibility, you can get different bases that give legitimately different results. The key takeaway is that you want your feasibility, optimality, and integrality tolerances to be less than the smallest meaningful coefficient in the model. So in general, that's a general tip that holds. And I see a lot of models with meaningful values of, say, 10 to the minus 7th, where people still leave these tolerances at their default of 10 to the minus 6. For this specific model, what that says is you got to consider the data like we saw before and ask yourself, is this 8 times 10 to the minus 8th value meaningful, or is it round off error? If it's round off error, you get rid of it and change the bound on y to 1. If it's meaningful, you should run with a feasibility tolerance of 10 to the minus 8th. And let's go on to the next slide, which illustrates a specific situation where this can arise. So here's a branch and bound tree, and we've got these green nodes that are feasible nodes, and we have so integer feasible nodes, and then we have the gray ones are infeasible or cut off, and the red ones are unexplored. Okay, so let's consider one of the feasible nodes, and somehow there's a base, there's a node LP solved there, and there's a basis, which I'll call B1, associated with that optimal node LP solution. Now let's suppose that we modify the model in a way that doesn't change the constraints. So for example, we change the objective. That shouldn't affect feasibility. Okay, now let's say we're going to use this solution from the first model as a MIP start for the second model. Well, that results in a MIP start subproblem. It could be an LP or MIP, but that model ultimately is going to solve and have a basis B2 associated with the MIPSTART subproblem optimal solution? Well, if the model's right on the boundary of feasibility and infeasibility, we're in precisely the situation of the previous slide. And therefore, we could very easily have the MIPSTART be rejected. And we have had customer calls like that. Okay, let's move on to our last example. So here we have the Grinch, where it's not about precision, it's about sort of counterintuitive characteristics of math programming. So we have a very benign looking model with 8 general integer variables and a single constraint, which we could view as an equality-based knapsack constraint, where each of the coefficients represents the weight of the 8 different objects that can be put in the knapsack, and you can put some number of them. All right, so this looks pretty benign, so let's see how Gurobi does. And yeah, the results are pretty benign. It solves very quickly. Okay, and yeah, before you ask, well, you're doing some numerics hocus pocus here, you know, something about boundaries of feasibility and infeasibility. No, that's not involved here. The solution has perfect quality with no violations whatsoever. All right, so now enter the Grinch, and he says, well, let's just change one coefficient of one object and make the weight 1 unit larger. And let's see what happens. Okay, so, okay, after 6 minutes, we've got over 1.2 million nodes and the active 1.2 million unexplored nodes.
11 million.
Growing. So this doesn't look good. Let's keep going a little bit. Yeah, after 20 minutes, it's only getting worse. Okay, so what happened here? You know, what's the story here? Well, we did make the model harder. We increased the weight as opposed to decrease the weight. And that's an important distinction. We're consuming more resource, and that can make a model harder. And we get this question a lot of, I made a simple change to my model, and now it's running much slower. And as we saw before with the convexity, non-convexity case, you need to distinguish between models that are in some way making the model tighter, more restrictive, from those that are making it less restrictive. And that's one of the key takeaways here. So more generally, consider the nature of the problem modification beyond this more versus less restrictive. And then if you want to try to figure out, there are some ways to generate some cuts to get this particular model to run faster. And some of the ideas in our previous 2 tech talks discuss that. And then there's also a paper that actually gives the answer if you want to read the answer rather than just do the exercise and try to figure it out yourself. Okay, so I think it's time to move on to our takeaways.
So we're a little bit stretched on time, but I'm just going to point this out. The heart is full. The Grinch is happy. And what happened then? Well, in Whoville, this is the final part of the book. They say that the Grinch's small heart grew 3 sizes that day. And then the true meaning of Christmas came through. And the Grinch found the strength of 10 Grinches plus 2. So yes, the Grinch was difficult, but he came round, and we found what was going on with the you know, what was going on, and we explained the inexplicable behavior. And this is kind of the moral. At the end of the day, all is well. You can figure it out. It just takes some time. Take-home messages here very briefly. I know we're at the top of the hour. First of all, cut us some slack. You know, writing an optimization solver can involve really difficult decisions. So it's not always easy. We're trying our best. We really, really care. The other thing is double check assumptions that start with, this should work. It's very dangerous territory. Be careful with your data. We've seen, you know, many of the Grinches involve numerics in one way or another, or data. changes one way or another. Data is not all created equal. Pre-sov is also very unpredictable. When an unusual behavior happens, try switching it off and see whether this helps. One thing that's not on the list here, but remember, if you see something, say something. If there is something that is unusual, do point it out to us and we'll try to identify what's going on. And there are some excellent resources that are going to be shown also in the next slide about counterintuitive and mythical behavior and mathematical programming. It was a real pleasure having you. And Ed, Kostya, final words from your side?
Kostya, you want to go first? Richard, yeah, do you have control back of the screen? There's
Yes.
no reason for me. Okay. Kostya, go ahead.
No, I think there's not much to add here. I think I can re-emphasize or reinforce, if you see something, say something. It's not just that, writing a solver involves difficult decisions. Those decisions have in many cases already been taken. So it's likely that we know something. So an answer to the why questions that you don't, because we have the code. Quite simple. So the best thing you can do is reach out and get clarity on that. Quite simple. I think that's pretty much it. So today was a selection. We have more. Not all of them made it through the embarrassing filter, but hopefully there was a good view of the spectrum of things that we see every day. Ed?
Yeah, the one thing I would add is I really like this notion of filtering to simplify things that we used in the convex, non-convex case. That really applies in a lot of cases. Other than that, I think that's all I have to add. As we usually do, we will stick around for any additional questions posted in the Q&A. But for those of you, who need to leave right at the hour, you're free to go.
Here's the list of references with a link to the Tech Talks, the book by Greenberg, and also the paper that Ed and Alexandra Newman wrote. It's been a pleasure.
Good. Then let's see. In no particular order. One remark to the Opti Grinch example with that equality knapsack constraint was that, if you look at it, it has, the coefficients are not too small, and also the right-hand side has 8 digits. And so the remark is probably, shouldn't that, be a warning to you? Ed, do you want to take this one?
Yeah, so the answer is both yes and no. Yeah, it's definitely good to make that observation, and ultimately, to a certain extent, that is in play here. I said that this was essentially a constructed model, but it is possible to construct similar models that don't rely on that big right-hand side value. So, if you want to read about this class of models, there's a paper by Karen Ardall that is referenced in the paper in our references section today that describes how these things work. But again, like I said, I was working on another model just the last couple days, where you change the right-hand side value from -1 to 0, and it goes from unsolvable to optimality to trivial. And there were no shenanigans with 8-digit coefficients anywhere.
One more thing I will add here is that actually 2 things. First of all, if you change this to being all continuous variables or being an inequality constraint, you won't see this problem, right? And this is something this is why also you have to be disciplined when you write your model, because this might be what the business says. The business tells you, yeah, our budget always has to add up to this number. But then you have to put your, Gurobi Grinch hat on and be like, wait a minute. Whenever I see something that says exact, let's be, this is business people talking exact. Let's add some slack. Let's add some, other things with it. And the other idea here is that when you make these changes, this is actually really, if you think about it in a different way, this is actually really cool that Gurobi can solve the exact knapsack constraint precisely. You know, like there's a lot of like, if you were to write a branch and bound solver yourself and you give it this constraint, it will die. I promise you. But because Gurobi has spent decades of trying to make the best of what it has, it's able to understand the structure and solve the problem instantly. Ed.
Yeah, well, so going back to our previous tech talks, we talked about the disconnect between the system for the LP relaxation and the MIP. So there's a picture I like to use for this exact knapsack problem, which is you have a truck with capacity given by the right-hand side. And now you have these 8 objects, each with a certain pick a metric, weight, volume, whatever. You know, the right-hand side is some volume, and the left-hand sides are the amount of volume consumed by the individual objects you want to put in the truck. So the MIP says you have to fill up the truck exactly. If you relax integrality, basically what you're saying is, I get a new process that allows me to chop up these individual items into arbitrary chunks. And then I can put these arbitrarily small chunks of an individual object into the truck to fill it up exactly. So the LP relaxation is just totally disconnected from the MIP. So it's not surprising that the LP relaxation is easy. And as we saw in the node logs, you know, the node LP solves were all super fast. That was not in any way an issue in the problem solve. So with that, I lower my hand.
But Ed, maybe another way of, and I think this is close to another question that we got here. I mean, there's a particularly ugly family of problems that is, they are in fact MIP or IP infeasible, but LP feasible.
Yes.
So the integrality constraint is what creates the mess here, so to say, and it can take forever to prove infeasibility if you cannot strengthen the formulation before you try. And so I think that the point here is not that you try to change the formulation in a way that you get to something feasible faster. The idea here is to change it in a way that you detect infeasibility faster, right?
Right.
Okay. Yeah. Because that was a question. I think that is what the question means. Does an IFS mitigate this problem, which is probably in something with infeasibility? And
so did the question poster mean IIS, although F and I
probably on my keyboard I and F are not too close.
Yeah, same here, but still, you know, sometimes we just type words that we're used to. It's not a question of missing the key.
Yeah. Initial
feasible
feasible solution. I've learned a new acronym. IFS, initial feasible solution.
Yeah, you could. I mean, I think that would, you know, I would say, you know, running Gurobi's fees relax would be a good test to see what's going on. I believe I've done that though, and unfortunately, I think what happens is it spends a long time and never finishes either. But that would be a good double check to do. You know, that may have been a long time ago. That would be a good, interesting test. Or zeroing out the objective you could try. But as far as that one goes, I can guarantee you it won't work. So actually, somebody's now asking, well, how would minimization work? I think you'll find that if you change the objective in any way on this model, minimize, maximize, zero it out, you know, change the objective coefficients to things like pi and E and the golden ratio, you're always going to get the same performance issue. It's not about the objective, although those are good questions to ask, because in many cases, changing the objective can fundamentally make the problem easier or harder to solve. So I think we've answered the question. Yeah, we've answered that question. Okay, should we go to the next one? Or do you guys have, yeah.
No, I think I wouldn't say we've beaten this thing to death, but there's probably not much more to say about this model. I remember giving lectures many years ago with these, with equality knapsack models, and they were so good because it wasn't not just that it, essentially the solvers were branching to death, so to say, but also they ran quickly out of memory. But then in the next lecture, when I installed the latest version, I tried it again, and it suddenly solved. That was embarrassing to me because I was supposed to show something that breaks state-of-the-art solvers, but it didn't anymore. Yeah. So there's progress with every release. So there's another question here. I'll just read it. So the question is, sometimes I've observed if I have a minimization problem where I add an extra constraint, I would expect to see the objective value increase after the addition of the constraint, but I observe a decrease. Could the root cause be related to numerics?
Numerics can always be like when you don't know what to say, just say numerics. That's simplified, but actually, first of all, just a small correction here, being a bit stickler for exactness. The objective function value doesn't have to increase; it just shouldn't decrease. The constraint is redundant; it doesn't do anything. It shouldn't have any impact on the optimization. Now,
and it's the
I'll
optimal.
take a stab at this. I'll take a stab at this one. Sorry, go ahead, Kostya.
Okay. No, please.
So I'm suspecting this is a myth. But even if it isn't, there is there's always a tolerance here. So we go back to the finite precision one. Oops, why does this not go back? Where's the finite precision one? And so specifically here, the finite precision here can be that we terminate a MIP when the MIP gap is 10 to the minus 4. So the gap between the lower bound and the upper bound. But it doesn't mean that the solution we found couldn't have been improved by 10 to the minus 4 relative. So when you say decrease, and the decrease is more than the tolerance of the MIP gap, then it starts getting interesting. But if it's within the precision of the MIP gap, I will just tell you, tighten the MIP gap if you want to have a better solution. And then see what happens. I don't know, Ed, Costa, what you think?
Well, I agree with everything you said. I was going to ask the same thing, which basically was how much of a decrease, and also just to confirm, within what tolerance did you solve to optimality? But I'll suggest one other thing. So I like using infeasibility to get answers. So if I had this and I see this decrease and it does not relate to the MIP gap issue that you just described, the first thing I would do is I would go back to the original problem and add a constraint that the objective is less than or equal to the decreased objective value obtained by adding a constraint. So in other words, original objective was 100. You add a constraint, the objective drops to 90. Okay, go to the first problem and add a constraint that the objective is less than or equal to 90. If that's infeasible, get the IIS and see what that involves. That'll shed some light on what's going on. On the other hand, if adding that constraint and you find a feasible solution with objective 90, I'd look at things like solution quality. Like, is the solution with objective 90 of much lower quality? So like we had this example where the solution quality was all zeros. Suppose that was the case for the first problem. Solution quality is all zeros, but now you get a new solution where the solution quality is barely within tolerance, and you have some big objective coefficients that allow you to improve the objective for just small non-zero values. So that, of course, falls in the realm of numerics, but there are things like that. But yeah, constrain the first problem based on that better objective and see what happens. That's a first step. So with that, I'll yield to Kostya if he has any comments.
Yeah, I think most was already said. Maybe you could also apply another recipe that we presented earlier, which is just switch off pre-solve and see if it makes any difference. If it does, numerics is likely. Yeah. Okay. And I think we're through the questions.
Happy holidays again. Thanks for sticking around. Hope this last 15 minutes was useful to some of you.
And
all right.
thanks
Good.
for having us.
Yeah.
Happy holidays.